All right, before we begin the lesson today, there are two concepts that I want us to go through and review so that we can link our new learning with our old learning. So we have already talked about that if we go to simplify the square root of 9, that is 3, and that is because 3 times 3 would give us a 9. So we could write that that we know 3 times 3 equals 9, so the square root of 9 is 3. Now, that's what's called our principal or positive square root, and that's the one we deal with most often. But as we go to start into our lesson today, and we deal with a radical, a square root, in the context of an equation, we're going to have to look at the other square root also, meaning that if we take negative 3 times negative 3, the answer is also 9. So the square root of 9 can be 3, or it can be negative 3. And how we very often write that is that it's plus or minus 3, which means that the answer is at negative 3 or at positive 3. Now, what that means on our graph is that we have a x-intercept at the point negative 3, 0, and the point 3, 0. Now, the other thing we want to talk about is, what about when we have the square root of 0? And so if we talk about the square root of 0, and we talk about it being a principal positive square root, we really only have one answer here, because 0 can only be 0 times 0. There's not a positive 0 or a negative 0. So where over here we ended up with two solutions, when we go to take the square root of 0, what's going to happen when we go to do our graph is that we're going to see that our parabola is only going to have one solution. It is just going to touch the coordinate or the x-axis in just one place. Okay, so right here we looked at what if we have a square root of a positive number. We used 9. We could have used any number. Here we looked at what about if we have the square root of 0. And now we're just going to look real fast at what about if we tried to take the square root of a negative number. So let's say we try to take the square root of a negative 25. And so if we know what the square root means, it has to be one number times itself. If we tried 5 times 5, that would give us 25. And if we tried negative 5 times negative 5, that would give us 25. The only way that we can get that negative product is to make one of these positive and one of these negative. And then it wouldn't be the same factors. And so therefore, using our real number set, we cannot take the square root of negative 5. And so what we say is that there is no real solution. We cannot come up with two numbers that multiply together, same numbers, that equal a negative 25. Now, what does that look like when we go to look at the graph of this? So when we go to look at the graph of this, what that would mean is that our parabola is not going to cross over the x-axis at all. And so here, where we had a positive number underneath the radical, we were able to get 2 roots, which gave us 2 solutions. Here, where we had a 0 underneath the radical, we were able to get 1 solution, because the only thing we can multiply to get a 0 is 0 times 0. Here, where we have a negative number underneath the radical, we are unable to take the square root of a negative number, because we can't get 2 numbers that are exactly the same that multiply together to get that negative 25. And so that means there's no real solution. And so that means that our parabola doesn't ever cross over the x-axis. All right, the next thing that I want us to think about before we go into the lesson is what it means to have a square, okay? So I think that we think about very easily when we say 5 squared, that means to take 5 times 5. But one thing that I want us to remember also is that if we have something that looks like x plus 3 times x plus 3, that can also be written as x plus 3 quantity squared. Okay, so we have been writing our answers as this or this, and I see that most of us are still writing them like that. But as we go into our lesson today, we do want to recognize that what we have here is a square, just like we have here is a square, or just as if we would have x squared. Okay, all of those are squares.